Section 2.3 brings us to the idea of linear models. So just to kind of give you the reasoning behind doing this. In business and science, it is often necessary to make judgments based on past data. And our linear modeling will help us do this. So the easiest way to do this is the construction of a linear model using at least 2 data points. So the more data points you use, the better, but at least 2 are required for this method. So the rest of our lesson is going to center around this word problem. The number of full-time faculty members at Texas A&M University in College Station in selected years is shown in the table below. So we start with 2005 up to 2016, and we're given the number of faculty members. So part A says let X equals 5 correspond to the year 2005. So I'm just going to go above the table here and say, okay, these years are 5. That would make 2007, 7, then 9, 11, 13, and 16 are going to be X values that we'll use. What would the data points be? So that turns those into the first data point being 5 and 917, 7 and 990, all the way out to that last data point, 16 and 1187. Okay, part B says to use the data points for 2009 and 2011 to find the equation of the line between these points. So using that point slope method that we've worked on, we start with finding the slope. So if those are our 2 points, we do the y2 value minus y1 over x2 minus x1. And that's going to give us 77 over 2. Or when we're doing linear modeling, a lot of times our decimal values will be more meaningful. So we'll go ahead and calculate the decimal of this as 38.5. At this point, we could choose either point to work with our slope and do the point slope form. So I'm going to use the 2011 data point. So my equation would be y minus 1115 equals 38.5 times x minus 11. So like I said, you could use the 9 and 1038. And when we simplify it to slope-intercept form, they'll give you the same thing. So distributing my slope here. And then adding the 1115 to the other side, my linear equation would be y equals 38.5x plus 691.5. Okay, part C has a switch data points. It says now use the 2005 and the 2007 data points to find the equation of the line. And we're going to compare that to what we got in part B. So for part C, we start with our slope. We do y2 minus y1 over x2 minus x1. 73 over 2 in decimal form is 36.5. So keeping in mind that comparison idea, we can already see our slope is slightly different. And now I'm going to use the 2007 point for point slope form. So y minus 990 equals 36.5 times x minus 7. Simplify that to slope intercept. So distribute the slope. And add 990 to the right side. And let's look at these two lines in comparison. So we have 38.5 versus 36.5. That's not too far off, but they are different. But the y-intercepts are quite different. So in the grand scheme of things, these equations are different. And to determine a better line, we need to look at the residuals. And that may not be a word you've ever heard before. We're about to learn what that means. The residual is the difference between the actual values which we will label as y, and the predicted values which we will call y with a little up arrow above it. So just for reference, that is said y hat. And that's pretty common in business language. If you take a lot of business math classes, you'll talk about y hat frequently. So the residual, as it says, is the difference between those. So y minus y hat is what we will calculate. And the line with the lowest sum of squared residuals is the better line. So we're looking at past data. So we have this information that we know from the past what the actual number of faculty were. And we've got two lines that we just came up with using 2 points from that. And we want to see which of those two is the better. So this brings us to example 2, which is still working with that same data. We're going to calculate the sum of squared residuals for the lines in example 1C. I guess it's actually B and C. Okay, so from 1B, our y hat, the equation we came up with was 38.5x plus 691.5. So this is the process we'll follow to come up with our sum of squared residuals. So we have our list of x values and the actual y values that come from the original table. Then we have the predicted y, which is y hat. And then once we have all of those written down beside each other, we'll calculate y minus y hat and square it. So the residual is y minus y hat. The squared residuals is y minus y hat, then squared. Okay, so for our x values, we had 5, 7, 9, 11, 13, and 16. The actual number of faculty members, 917, 990, 1038, 1115, 1152, and 1187. Then for our predicted, from this point forward, you're going to want your calculator pretty handy for this lesson. So I'm going to bring up my calculator and show you the best way to get these predicted values. So yours will be side by side. But I'm gonna go into y equals, clear out anything that may be in there and type in the equation we came up with. So 38.5x plus 691.5. And I want to find the y values that correspond to the x values in our table. So to bring up a table, I push the second key and then graph, because above the graph is the word table. And we start with 5. So at 5, we have 884. And then the next one is 7 is 961. So I have 884, 961, and then you can follow along with your calculator. At 9, I have 1038, 1115, 1192, and 1307.5. So notice the two ordered pairs that we use to make this line match exactly as they should. So it takes those two data points and extends beyond those to make a line that sort of fits, and we can see how closely those values are. So now to calculate this last column, you take the y value, subtract the y squared value, and whatever you get for that, you square it. So I'll do one of those on the calculator and then I'll go back and write them down. So the first row was 917. You do second and the mode button for quit to get out of your graphing anytime you're graphing. So 917 minus 884, hit enter. And then to square is the button just above the word that says, or the button that says log, and it will square that answer and I get 1089. So my first sum of squared residuals is 1089. You do that all the way down the table, you get 841, 0, 0, 1600, and 14,520.3. And remember, we are supposed to calculate the sum of the square residuals. So we have the residual squared. If we just add up that whole column, you get 18,050.3. Okay. So now for 1C, we're going to repeat that whole process. For our second line, we wrote 36.5x plus 734.5. So the first two columns of my table are exactly the same because that comes from the original table we were given. 5, 7, 9, 11, 13, and 16 with y values 917, 990, and so on. Okay, then we come up with our y hat. So put this into your calculator, push second graph to bring up the table, find the correct x values, and write down the y values. And then go through each of those and find the difference between y and y hat and square it. So the first two are the 2 points we used to make this line, 5 and 7. So those have no residual. They're exactly on our line. And then you start to see the variance in the other points. So that's supposed to be a 25. Okay, after you've created that whole table, again, you calculate the sum of your residuals squared. And I got 21,607.25. So in comparison, the square of the residuals of the first one is lower than the second one, which means it is a better line. So just to make a note of that, the first equation has a lower sum. So it is the better line. Notice the word better. So we compare those two, and of those two, it is the better line. The question is, how can we find the best line? We don't want just the better of two lines that we came up with. We want to know what's the better line. So this is what we call the line of best fit. The line of best fit is called the least squared regression line. Least squares regression line. In the computation process, for finding this line is called linear regression. So to do linear regression by hand means you repeat the process that we just did for those first two lines for every possible combination of the points that you have in your table. But this can be done on the calculator. So the calculator has built-in functionality to go through and create all of those lines, regression lines, and see which one is the best fit. So for example, number 3, we're going to find the line of best fit for the data in example 1. Okay, so for this, rather than use the calculator on my iPad, I'm going to switch to one on my computer that matches the model that you have a little bit better. So let me do that switch here. Okay, so this should look very similar to the calculator that you have. I'm going to be working on the right side, and as I press buttons, you'll notice they turn red, but also down here at the bottom, you get a key press history. So if you miss a button that I push, you can look down here for the sequence of buttons that I've pushed. So I'm going to clear that at this point so we can start fresh. So you have a formula chart or formula sheet in the course content that walks you through these steps. So I'm going to go through them relatively quickly, but know that you can go download that formula sheet that has all of the steps in it for you. So I'm going to start by creating a list. So I'm going to push stat and edit number 1. And I have some lists in here from previous classes. If your calculator has that as well, you're going to arrow up to where the title of that list is, in this case, L2, push the clear button and the down arrow, and it will clear that whole column. So I'm going to go do that for the first column as well. Clear down, and now I have a fresh, clean list here. So in L1, I'm going to put my X values, and I'm going to type each one and push enter. Even after the last one there, I'm going to push enter. So let me double check. 5, 7, 9, 11, 13, 16. Okay, and I'm going to arrow to the right. It takes me back up to the top, and I want to put my Y values here. So 917, 990, 1038, 1115, and 1152, 1187. So if your bottom 2 rows don't line up, that would indicate that you got off somewhere on your data input. and go back and double check that. If you need to completely start over, if you get some error messages, the sequence of buttons that will best reset your calculator is second, then the plus sign, and then the numbers 712, followed by second, the plus sign 722. So anytime your TI-84s give you any kind of trouble, that's a good sequence of presses to reset the calculator. Okay, so now we have this data entered. I'm going to do second and the mode button to quit out of that, and that's how the list gets saved. Okay, so now I want to do a calculation. So I'm going to push stat, arrow over to calc. And you can see this list. If you read number 4, it says linreg. That's our linear regression. So I want option number 4. And you should see this. It asks you which list to use as X values, which list to use as Y values. And you just have to push enter on your calculator down all the way to the bottom. The last one is basically a question or a command to calculate. So I push enter and it calculates. So for most of us, this is what you're going to get when you run. There are a set of regression statistics that we need. So sometimes I don't remember to turn the statistics on until I run regression the first time and I don't get everything that I need. So what this is giving me is the slope and the y-intercept for my equation. But I need to know another value. So first, let's just write that down. So let me write this down and then I'll go to my screen and show you what I wrote. So 25.1567x plus 810.7402. And it's a good rule of thumb. You just want to write down 4 decimal places. Okay, so from my linear regression I did on the calculator, I wrote down this y hat. And the question I'm asking myself now is, how good is the fit? Is this a really, really good fit, or is it just the best we could come up with? So I'll give you one more definition here, something called the correlation coefficient. And this is that statistic I was talking about. The correlation coefficient is called R. And that measures how closely the data fits the model for predictive purposes. This is always between -1 and 1. So close to -1 or 1 is a great fit. Close to 0 is bad. So you kind of have this middle point of 0 that's not a very good fit. And the farther you go to +1 or -1, the better your fit is. So for example, number 4, we're going to figure out what is the correlation coefficient for our model in example number 3. Okay, so let me switch back to my calculator application. And here I need to turn on diagnostics. So the easiest way to me to get to that is using something called the catalog. Look above the 0 button on your calculator and you see in blue the word catalog. So I'm going to push second 0. And this brings up every possible command your calculator has. Well, the one I want is called diagnostics, which starts with the letter D. So you'll see the letter D in your alpha color. My alpha color is green, and I see a D right here. So it's already in alpha mode because of this A in the right-hand corner. I know that. So I'm going to push this X to the -1 button. And it takes me to the D's. That just jumps so I don't have to scroll as far. Now I'm going to push my down arrow and scroll until I see diagnostic on. So I get to that line, push enter. It brings that command to the calculator screen, and I push enter again to actually turn them on. So done means your diagnostics are turned on. Now we have to rerun the regression to get our R value. So fortunately, it saves the list unless you did a clearing sequence, the second plus 712. Your lists are still there, so you just have to redo the calculation. So that's pushing stat, arrow over to the calculate menu, and you want option number 4. You can either arrow down and click it, or you can push the number 4 and then go to the bottom and calculate again. So now you see 2 extra pieces of information here. We get an R and an R squared. So sometimes you're going to look at R, sometimes you're going to look at R squared. They have a slightly different meaning, but basically the same thing. So if you're just asked for the correlation coefficient, that is R. So we're looking for R in our output. I'm writing this down on my notes, and I'll come back to that in just a second. So for us, R equals 0.9806. Switch back to my notes here. So I indicated, just so that you'll remember when you look back at your notes, we looked for R in the output. I wrote down my R value. The closer it is to 1, the better. So this is a very good model because our number is almost 1. Okay. So then once you know it's a good model, you can make predictions about the future. So our data took us all the way to 2011. We want to predict what the value will, no, it took us to 2016, sorry. We want to predict the value for 2015, which was missing from our table. So what is the predicted value for 2015? So that means we're using an X value of 15 in our Y hat. So 25.1567 times 15 plus 810.7402. That's our Y hat from up here. If you calculate that, you'll get 1188. So that many faculty members are about how many there were in 2015.